Hey guys, we're going to take a look at the last paragraph of chapter 7, paragraph 7.5, which is going to be about corresponding and alternate angles. Okay? And we're going to start with the, crazy enough, with the alternate angles, not with the corresponding ones. So in the different order they give us here in the summary. What are alternate angles? I think, unfortunately enough, they changed the name in the book Numbers in Space from version 12 onwards, because previously this kind of angles were called z-angles. And you can also see that in the Dutch translation, alternate angles in Dutch zijn z-hoeken. And previously they called this z-angles as well. In this new version of Numbers in Space, they call this alternate angles. Okay. What does that mean? Well, in this case I would like you to remember the Dutch translation as well, because we're talking about certain angles in Z-shape like figures. So for example, right here in 7.41 in A you can find a Z-shape like this, right? What is a Z-shape? Well, this line here is parallel to this line here, and then you have a line that connects them. What turns out to be the case? Well, it turns out that this angle right here, angle A2, is going to be the same as angle B1. Okay? So alternate angles appear in shapes with parallel lines. This is a parallel line here and here as well. Just to notice, now I've drawn the Z like this, you could say, right? The Z shape. It also goes the other way around, but now it doesn't really look like a Z anymore. But you could also say that angle A1 equals angle B2. And this is also called, or this kind of angles are also called alternate angles. You can see that, right? If you know that B1 and A2 are the same, I can calculate A1 here by using my theory of straight angles. And since I will find a value here, it will have the same value of this one, because this will also be 180 minus this. And this is 180 minus this. But those two angles are the same. So A1 is also equal to B2. But please don't make the mistake to say B1 is equal to A1, right? They alternate. Ze wisselen af. Dat zit wel in de Engelse vertaling. So this one is on this side of the line, the other one is here. And this only occurs when the lines are parallel as well. How can we use this information? Before we're going to do, here are a couple more examples that the book gave you and a few examples that I've made myself. So as you can see, sometimes they can be quite well disguised, right? It's not that easy to see that there is a Z or a Z shape in here, but still these are called alternate angles here and there. They are parallel, they are connected, then this angle is the same as that angle. And you can also say that this angle is the same to that one. Here as well, this angle equals that one, but also this angle equals that one, and vice versa. And you see a few other examples that I've made down here as well. Okay, let's put this into practice. In figure 7.42, AB is parallel to CD. That's what those lines mean. They also state that in the picture. Angle A1 is 76 degrees and angle B1 is 63 degrees. First, a theoretical question: which alternate angle is equal to D1? So I have an angle right here. Which alternate angle is going to be equal to D1? There's only one possibility here. One tip: search for the parallel lines. This line is parallel and this line is parallel. So I can even draw in this if I want to, right? Yes, pen. My Z shape is right there. And because I want to talk about D1, it's nice that it is in this Z shape, you will see this one must be the same to the one over here. Alternate angles, so on the other side. So hopefully the angle is going to be E2. Ooh, I did it correctly. You cannot do that the other way around, right? Because this line is not parallel to that line. So I cannot draw a Z shape like here, right? This, for example, is not a Z shape. These are not alternate angles because this line is not parallel to this line. Okay? So let's delete that again. Can I do that? Yes, I have a gum. Okay, calculate D4 and angle C1. So they want us to calculate this one right here. Let's go back to my pointer. They want us to calculate D4 and they want us to calculate C1. How would you start in this case? Well, I think we have to use our knowledge of course, alternate angles here, but also our knowledge of straight angles is going to come quite in handy. First, you could say that angle D4 is just directly equal to angle A1. Right? I know that because there is a Z. I can again draw it for you guys. Pen. There is the Z shape right here. And then you have this one must be equal to that one. Okay, so this one doesn't involve any calculations, but remember to write down alternate angles inside of brackets afterwards. You have to write it down again. How can I find C1? Well, which angle is equal to C1? Try to answer that for yourself. I think that angle C1 is equal to angle C4. So you can do it now in two ways. The book says, well, I'm going to say that angle B1 equals angle C2. There's the Z formation right here. So those two are alternate angles. And then they say, well, if I know C2, I can calculate C1 using the straight angle rule. 180 minus 63 gives me 117. Can you do it another way? Yes, you could also have said, well, I'm first going to say that, let's see, am I correct? Yeah, I could also done the straight angle rule here. So then I found that B4 is 180 minus 63 is 117. And then say, because of the alternate angles, that C1 is equal to B4, which also gives me 117 degrees. Then I'm doing the rules in a different order. You find the same thing. So you will find that if you have calculations in this part of the paragraph, you have to combine them with your knowledge of straight angles a lot. Remember that, please. Try to do the exercises. And in the next video, we're going to take a look at the other special kind of angles that we're going to talk about, the so-called corresponding angles. See you then.